Hello, I'm Nick, and this is Today in Philosophy of History for Monday, 19 February, 2024. It is the 551st anniversary of the birth of Nicolaus Copernicus, who was born in Torun, which is now part of Poland, on this date in 1473. Copernicus' heliocentric model of the solar system, which was presented in his book De Revolutionibus Orbium Coelestium, on the revolutions of the heavenly spheres, or of the celestial spheres, if you prefer, which he had worked on for most of his life, on and off, was published just before he died in 1543. And this is a convenient date to fix as the beginning of the scientific revolution. Whenever we want to name a period, we're faced with the dilemma of, what date we're going to use to start the period, because there are always many alternative possibilities. And I often use 1543 as the beginning of the scientific revolution because of the publication of Copernicus's book. And it appeared more than a half century before Galileo's Sidereus Nuncius, the Starry Messenger, which he was able to write because of his telescope observations. And Copernicus was, like I said, a half century before that. Copernicus belongs to the very few scientists in history whose name has become an adjective, with Copernican being as familiar to us as Newtonian or Darwinian. And like Darwin, many centuries later, Copernicus hesitated to publish his big book to explain his big idea, that is to say, the idea of heliocentrism. Both men, Darwin and Copernicus, understood the impact that their ideas would have, though probably both of them underestimated the eventual influence of these ideas. And both transformed the world and left an entire cosmology as their legacy, you could say. The particular details of the Copernican system are less significant than the Copernican idea, that is, Copernican cosmology, which has gone on to have a continuing influence in scientific thought and in ordinary thought in the age when science dominates the public conversation, you could say. Anytime there is a demoting or decentering of human beings from any center, whether physical or metaphorical, it's called a Copernican demotion, or a new aspect of Copernicanism. Once again, to compare the two, Darwin eventually published his book, Origin of Species, in his lifetime, partly prodded to do so by receiving what's now called the Ternate essay that Wallace sent him, that he wrote after seeing natural selection in a fever dream, essentially, when he was sick. But Copernicus put off publishing until the end of his life. It is said, probably this is merely apocryphal, that he was shown a copy of the first edition of De Revolutionibus on his deathbed. But Copernicus lived much closer to the medieval world than did Darwin. One could argue that Torun and Frombork in the 15th and 16th century was essentially a medieval world, so we can readily understand Copernicus's hesitation to publish. Darwin published in a world already transformed by industrialization, already wrenched by unprecedented social change. Copernicus eventually published in a world that was on the brink of profound change, but had not really appreciably changed in 1,000 years. Copernicus's hesitation in publishing meant that he didn't directly supervise the publication of his manuscript, and he wasn't able to correct or revise any subsequent editions. Darwin made 6 distinct revisions of his Origin of Species in his lifetime, not including the translations. And Copernicus was not able to respond to the reception of his book. And all of these conditions proved significant in the reception and the propagation of Copernican heliocentric cosmology. When Copernicus was eventually galvanized to pursue the publication of De Revolutionibus, This was primarily because of his contact with Georg Joachim Rheticus, who had traveled to Frombork for the purpose of meeting Copernicus. Copernicus's reputation had preceded him. Rheticus, who had great respect for Copernicus's achievement, came from the hotbed of Renaissance and Protestant scholarship that was Nuremberg. He took Copernicus's manuscript to Nuremberg to be published by a noted scientific publisher of the day, but Rheticus himself didn't stay to oversee the entire publication of the work. So that job got handed to Andreas Osiander, who was a Protestant theologian who sought to water down the potential impact of De Revolutionibus by adding a preface that suggested that Copernicus's theory should be accepted in the spirit of a hypothesis employed for the convenience of calculation, which is a story we've all heard many times. Osiander didn't sign the preface that he wrote, and many readers of the book, when it did eventually come out, assumed that the preface was by Copernicus and represented the authentic Copernican interpretation of the text. Osiander's preface, and whatever his intentions were in writing the preface and changing the title of the book, continued to be debated by historians down to the present. And this debate cannot be cleanly separated from the turmoil that surrounded the Protestant Reformation. Luther and the Lutherans were critical of Copernicus. They had staked their legitimacy on the legitimacy of their movement on biblical literalism. But you would have thought that the Protestants would have been friendly to the implicit parsimony that's present throughout Copernicus's work. Because the parsimony we find in Copernicus grew out of the work of William of Ockham. And given Ockham's conflict with the papacy, his fideism, and his implicit position as a critic of Thomism, he could be taken as an ancestor of Protestantism. The parsimony of Copernicus's formulation of cosmology was a mixed message to the early scientific revolution in the context of the Protestant Reformation, and I will come back to this in a bit. Both Rheticus and Copernicus' friend Tiedemann Giese were indignant over the unsigned and unauthorized preface by Osiander. Rheticus, by some accounts, was furious and felt that that both the book and Copernicus had been betrayed by it. And he pursued some limited legal action against the printer, but it's not clear that the printer was at fault for the preface. It seems to have been Osiander's work. Though Rheticus suspected that Osiander was the author of the preface, that was not confirmed until later, and by that time Rheticus had moved on to other things. So Osiander was never legally pursued over this. I brought up Occam's razor because the most common reason that is presented for accepting Copernican cosmology to Ptolemaic cosmology is not that the one is true and the other is false, though this is certainly a reason to prefer Copernicus. The most commonly cited reason is that Copernican cosmology is a simpler and more straightforward explanation for the observed movements of the stars and the planets. The Ptolemaic system can predict the movements of stars, planets, and the moon within a margin of error that is relevant to his time, but it does so by way of a much more complex and cumbersome method than that of Copernicus. Copernicus was radical in his disestablishment of traditional cosmological thought. But once you get beyond the first step of radicalism, of displacing Earth from the center of the universe, the solar system fell into place quite neatly, according to a simple plan that anyone can understand once it's explained to them. The sun at the center and all the planets revolving around it. Seen from the perspective of our orbiting and rotating Earth, the other planets also orbiting the sun appear to reverse in their course, and that is to say they exhibit what is sometimes called retrograde motion, but that's just an artifact due to our position as observers. It is cosmological appearance, but not cosmological reality. We very often find in the scientific revolution that there is an implicit metaphysic of distinguishing between appearance and reality, and what we have to date accepted as reality has to be overturned and understood as mere appearance that is a manifestation of an underlying reality. Here, the underlying reality is the heliocentric theory of the solar system, and the appearance is the retrograde motion, which suggests some other kind of structure. Once Copernicus can convince the reader that despite the apparent solidity of the Earth, that the Earth is in fact moving through space, everything else falls into place. One of the reasons that the theoretical parsimony and elegance played such a significant role in the reception of Copernicus, and even the theologians who rejected his cosmology employed his calculations to clarify the calendar because the method was so good, was that the evidence given for the Copernican system was indirect. Even today, only a handful of the entire human population has ever left the planet Earth and looked down on it above and seen the Earth from the perspective of what Frank White calls the overview effect. And these are the only people in history who have acquired direct evidence of Earth in space. No one, not a single human being, has hovered above the entire solar system and looked down on it and so obtained the most direct evidence of the Copernican theory, which would be the observation of planets orbiting the sun. The knowledge that we have of our solar system and of the universe entire is derived from observations and deductions from observations. Seeing the truth of Copernican heliocentrism would not only require an overview in space, hanging above the sun and seeing the Earth, the planets, including Earth, orbiting, but it would also require an overview of time, because you need to hover over the solar system literally for hundreds of years to see all the planets rotating around the common center of the sun. The orbital period of Pluto is about 249 years. So to see it all go, you'd have to be up there for a quarter of a millennium, and to see it repeat, so to have some repetition in your observation, you would have to stay up there for a very long time. And no one can remain focused on observing the entire solar system long enough to be able to see the entire process. It's a feat beyond the limitations of a human lifetime, not to mention a feat beyond the limits of human consciousness. Copernicus himself didn't mention the principle of parsimony or Occam's razor, and he certainly didn't mention William of Occam, though Occam was widely read in Copernicus's time. I suppose it would be an interesting exercise to see what copies of Occam's work were in Polish libraries where Copernicus resided at the time. But the principle of parsimony is implicit and even pervasive in Copernicus, as it is in all good science. We don't want to account for the universe with Rube Goldberg-like contraptions and explanations. In a much later era of scientific thought essentially of our own time, at least my own time, the 20th century, Stephen Jay Gould wrote an essay titled, I think it was his very first work, was a paper titled, "Is Uniformitarianism Necessary?" He argued for the view in this paper that uniformitarianism geology has simply come to mean that geology follows the scientific method, and it is therefore a naturalistic body of knowledge. By the same token, one could argue that parsimony is no more necessary than uniformitarianism, and what the content remains of parsimony is simply that any parsimonious investigation is coextensive in that respect with the scientific method. To practice science is to reason in accordance with Occam's razor, but we need not explicitly invoke or apply Occam's razor because its prescriptions are already assimilated into the scientific method. Most scientists don't need to think long and hard about parsimony because parsimonious formulations are already a feature of their work. If you follow the scientific method, you will practice parsimony as a matter of course. Copernicus's Occam, then, is an Occam already absorbed into nascent scientific thought. And perhaps it would be better to say that parsimony is implicit in the scientific method, and Copernicus, in implicitly following a scientific method that had not yet in his time been explicitly formulated, was following the internal logic of the scientific method and his parsimonious demands for simplicity. Osiander's parsimony is something else. Osiander was, as I mentioned earlier, bitterly criticized in his own time for his unauthorized preface to De Orbis De Revolutionibus, though it was immediately recognized by many that this preface was a gambit to allow for the reception of Copernicus's work to involve the least amount of controversy. In other words, Osiander was trying to pave a way for Copernicus to have the influence he did by taking the sting out of it, as it were. As I mentioned earlier, the Protestant Reformation was in full swing, and the events that would lead up to 30 Years' War were already beginning to unfold. Europe was a powder keg, and a lot of people thought it was the better part of valor, as it were, not to touch a match to that powder keg because it's going to explode at any time. At the same time, there were others who were doing everything in their power to provoke a conflict that would settle matters, or they believed would settle matters once and for all. Osiander's preface and his change of the title can be understood as a concession to the intellectually conservative establishment of the time, or it can be seen as capitulation. But it was the preface and what the preface claimed as the proper way to understand the work that was the nub of the complaint against Osiander. So I'm going to read a longish extract from the preface, Osiander's preface to De Revolutionibus, without reading the whole thing, just a good chunk of it to give a sense of it. Quote, "It is the duty of an astronomer to compose the history of the celestial motions through careful and expert study. Then he must conceive and devise the causes of these motions or hypotheses about them. Since he cannot in any way attain to the true causes, he will adopt whatever suppositions enable the motions to be computed correctly from the principles of geometry for the future as well as of the past. The present author has performed both these duties excellently. For these hypotheses need not be true nor even probable. On the contrary, if they provide a calculus consistent with the observations, that alone is enough. Perhaps there is someone who is so ignorant of geometry and optics that he regards the epicycle of Venus as probable, or thinks that it is the reason why Venus sometimes precedes and sometimes follows the sun by 40 degrees or even more. Is there anyone who is not aware that from this assumption it necessarily follows that the diameter of the planet at perigee should appear more than 4 times and the body of the planet more than 16 times as great as at apogee? Yet this variation is refuted by the experience of every age. In this science, there are some other no less important absurdities which need not be set forth at the moment. For this art, it is quite clear, is completely and absolutely ignorant of the causes of the apparent non-uniform motions. And if any causes are devised by the imagination, as indeed many are, they are not put forward to convince anyone that they are true, but merely to provide a reliable basis for computation. However, since different hypotheses are sometimes offered for one and the same motion, for example, eccentricity in an epicycle for the sun's motion, the astronomer will take it as his first choice, that hypothesis which is the easiest to grasp. The philosopher will perhaps rather seek the semblance of truth, but neither of them will understand or state anything certain unless it has been divinely revealed to him," unquote. If we eliminate the final qualification stated in this extract from the preface, quote, "unless it has been divinely revealed to him," unquote, Osiander's preface is a straightforward argument for what we would today call instrumentalism. Osiander recommends Copernicus's work because it gives the right results. We can stop there if we want to, and we don't have to make any metaphysical claims on behalf of the theory. This ought to sound very familiar to the modern person, because this kind of instrumentalism has been very common in the logical positivist interpretation of science, which dominated the interpretation of science in the early 20th century, and its variations on the theme of the same philosophical school of thought continue to inform our interpretation of science. And especially today, it informs the interpretation of quantum theory. Quantum theory is the most thoroughly confirmed theory in the history of science, confirmed to a degree of precision that's almost beyond human comprehension. But quantum theory lacks any intuitive interpretation. We use quantum theory because it gives us the right results. That is to say, we use quantum theory instrumentally, but many scientists hesitate to give any kind of metaphysical interpretation of the theory, and those metaphysical interpretations that have been offered are usually profoundly counterintuitive, and they constitute something of a barrier to a wider, what could you say, extrapolation of quantum theory. And we know that classical theories like general relativity still haven't been assimilated to the quantum paradigm, despite, like I said, quantum theory being a highly confirmed theory and the obvious desire for a quantum theory of gravity. Copernicus was a staunch scientific realist, like I think most of the people who were convinced of the truth of his theory, like Rheticus. He did not propose his cosmology merely as a system of calculation, but he insisted that his theory was the true theory describing the motion of planets around the sun. It follows from this uncompromising scientific realism that other theories are not merely less precise and less efficient in calculating the movements of the planet, but they are, in fact, false. Scientific realism accords with common sense realism when it comes to the idea that there is a correct account of the world, and other accounts that deviate from the correct account of the world are false. But we all know that scientific theories are underdetermined by the evidence. To formulate a law of nature is to go beyond finite evidence to be able and to predict an infinitude of possible consequences and states of affairs of the phenomenon that is predicted by the law of nature. So scientific realism is in an ontologically robust position because of this underdetermination. You could say that the ontological robustness is a function of the underdetermination of theory by evidence. Osiander argued that Copernicus's theory was that, quote, if they provide a calculus consistent with the observations, that alone is enough, unquote. So Osiander was not willing to go beyond the evidence and posit the truth of an underdetermined theory. And in addition, Osiander was willing to maintain empirically equivalent theories, quote, since different hypotheses are sometimes offered for one and the same motion, unquote. Given empirically equivalent theories that can both provide a calculus consistent with the observations, why would one theory be favored over the other? Osiander states that the astronomer will prefer the simplest explanation, hence explaining Copernicus' position, while the philosopher will seek a semblance of truth. Neither, however, according to Osiander, can know what this truth is without divine revelation. Osiander's Occam is the convenience of the astronomer to seek the simplest explanation for his calculations. The astronomer is justified in employing the simplest explanation of the most precise method available to calculate and predict the course of the heavens, but he can't know the truth of his theory unless that truth is guaranteed by some outside and transcendent evidence not available through science, what you could call a deus ex machina for the mind, which is what you could say revelation is. We see from this that Copernicus stands at the beginning of the scientific revolution, and he nearly stands alone. Copernicus's Occam was ontological parsimony. Osiander's Occam was methodological parsimony. So are we forced to choose between the two? Are we forced to find a balance between ontological and methodological parsimony? These are still living questions in the philosophy of science. And it's remarkable in a sense that this problem appeared so early in the scientific revolution. The world of Copernicus was essentially the medieval world. Torun and Fromberg were far from the medieval centers of learning in Paris and Oxford. and about as far from the Renaissance centers of learning in Florence and Nuremberg. However, the new cosmology that emerged from the scientific revolution, and which is still our cosmology today, continuously revised and improved since then, can be traced to the Baltic coast of Poland in the 15th and 16th centuries. The controversy how to interpret the findings of science can be traced to the same root. The conventions of the scientific method that were established in the work of Copernicus, Galileo, and Newton was the work of these seminal thinkers who established these conventions. Like the cosmologies of Copernicus, Galileo, and Newton, the scientific method has been continually revised and improved. That Copernicus grasped, in essence, as much of the scientific method as he did, as early in its history as he was, working in near isolation, far from the intellectual centers of Western civilization at the time, demonstrates both the power of Copernicus's mind and the power of the scientific method itself. Once grasped, the scientific method has an internal logic of its own that directs the development of scientific thought. The scientific method, which we can also call methodological naturalism, exists in an uneasy partnership with scientific realism, that is to say, ontological naturalism. We can see this tension was present right from the very beginning of the scientific revolution, before the scientific method was ever formulated explicitly, and the tension continues to the present day. Contemporary analytical philosophers discuss the questions of scientific realism in highly technical terms, but it's still essentially the same debate that began with Copernicus, Rheticus, and Osiander, and it was Copernicus who gave us a naturalistic conception of the cosmos based on ontological parsimony and ontological realism. So what does all this have to do with history other than the history I have been recounting so far? In my episode on John Lukács, I called Lukács's work as a historian non-Copernican. Oh, not only his work as a historian, but his several books on historiography. So what does it mean for history to be Copernican or non-Copernican? Well, for one thing, Copernican history is set in a naturalistically conceived cosmos. It's set in Copernicus's cosmos. And as abstruse as some of this might seem, it isn't difficult to see the difference between a Copernican and non-Copernican conception of the cosmos. I've lost count of the number of times I've heard or read that we are now in the present living in a pivotal moment of history, that we are, in a sense, at the center of history, and that the present is a privileged moment in time. This is closely related to the idea of crises in history. In several episodes, I have discussed the idea of crisis as we find it in Husserl, as we find it in Pitirim Sorokin and others, because the idea of crisis has played such a central idea in philosophy of history, but without sufficiently clarifying the scope of a crisis so we know what is part of the crisis and what is not. And with those parameters being so loosey-goosey, as it were, you can tighten up a crisis so it's very specific, or let out the borders of it, and so it takes in a very large period of history. You have a lot of latitude to say that we are in effect at the center of history because we are in a unique crisis at the present moment. The idea that one is present at a pivotal moment in history, and that one's actions in relation to the unfolding events in the present will play a decisive role in the world that is eventually to emerge from accelerated apocalypticism, can be thought of as the Ptolemaic equivalent of historiography, that is, an anti-Copernican history, a Ptolemaic history. Ptolemaic historiography, if there were such a thing, would insist upon the centrality of ourselves and our perspective in the history of the world, which is pretty much what Lukács did. holding that we have a privileged perspective on history as a consequence of our position in time. There is a more conventional way to understand this kind of claim. In the introduction to his lectures on the philosophy of history, Hegel made a tripartite distinction between three kinds of history: original history, reflective history, and philosophical history. The first of these, original history, is characterized by histories written by individuals who have witnessed events they are recounting, or who have heard about the events firsthand. These original histories are original in two senses. Firstly, they have observed the history firsthand or had it reported to them firsthand, and they are not only a witness to the events, they are witness to the spirit of time. That is to say, they understood these events in their historical context, and they were part of that context, so they understood what their contemporaries were saying and thinking and doing. You could say that the author of an original history shares the Weltanschauung or worldview of the participants in contemporaneous history, the contemporaneous history that they are recording. Ptolemaic history then is a form of original history because it's predicated upon the centrality of contemporaneous historical actors within their own perspective of history. Copernican historiography, on the other hand, would apply the Copernican principle in time as the Copernican principle has already been applied in space. And we already have a parallel to this in the cosmological principle and what Fred Hoyle called the perfect cosmological principle. The familiar cosmological principle was concerned with the spatial isotropy of the universe, and Hoyle's perfect cosmological principle extended this spatial isotropy to time as well, so it would be temporal isotropy. The perfect cosmological principle proposed by Hoyle, Bondi, and Gold as a supplement to the cosmological principle as conventionally understood was intended to justify their steady state model of the universe. And like the familiar cosmological principle, the perfect cosmological principle has been given many alternative expositions, none of which are precisely the same. So several examples. The article on Fred Hoyle from the Encyclopedia Britannica says, quote, "The universe on average is not only homogeneous and isotropic in space, but also constant in time," unquote. And the perfect cosmological principle in a 2015 paper, A New Perspective on Steady State Cosmology from Einstein to Hoyle by Cormac I can't pronounce this Irish name, and Simon Mitten, quote, "The universe should appear essentially the same to all observers in all places at all times," unquote, with "at all times" italicized. And here's a formulation of the perfect cosmological principle from the Routledge Encyclopedia of Philosophy. Quote, "A homogeneous distribution of matter in an infinite space and throughout an infinite time," unquote. One more, the cosmology article from, oh, never mind. I'm not going to use that right now. Hoyle's perfect cosmological principle was not widely accepted. A stock answer as to why it was not widely accepted is that Hoyle's perfect cosmological principle was rejected because of the observational pillars of Big Bang cosmology, and most especially the discovery of the cosmic microwave background radiation as confirmation of Big Bang cosmology. When Penzias and Wilson discovered it, and Peebles and others confirmed that that's what it was, that pretty much was the death warrant for steady state cosmology. But Big Bang cosmology ought to be understood as in the context of possible natural histories of the universe. The confirmation of any theory that postulates that the universe has a natural history would have been sufficient to overthrow the steady state model of the universe. The Big Bang model of cosmological evolution is one among a class of possible natural histories for the universe. If we must reject the perfect cosmological principle because the universe is evolving and therefore appears differently at different times, we must also reject the possibility of Copernican historiography as a rejection of Ptolemaic historiography. I'll come back to this, but I want to now consider some formulations of the Copernican principle, which, like the many versions of the perfect cosmological principle, we find many different versions of the Copernican principle. For example, in Hans Ringstrom, on the topology and future stability of the universe, 2013, quote, the strong Copernican principle, there are no privileged observers in the universe, unquote. The generality of this formulation is equally applicable to space and time unless the universe is construed to mean the universe only in its spatial extension and not its temporal extension. Here's another formulation. The Copernican principle has been a fundamental tenet of modern science since the 16th century and is also a cornerstone of modern cosmology. It states that we should not live in a special region of the universe, unquote. That is from Pengji Zhang and Albert Stebbins, Confirmation of the Copernican Principle at GPC radial scale and above, from the Kinetic Sunyaev-Zeldovich Effect Power Spectrum paper. The implicit distinction between privileged observers and privileged spatial locations appears in formulations of both the cosmological principle and the Copernican principle. An interesting distinction might be explicitly formulated on this basis, such that a privileged spatial region might exist, but if no observer existed at this location, then no privileged observations could be made. But I'm going to set that aside for the moment, except to say that a universe without an observer located in a privileged region of space is only a step away from a universe with no observers at all. The idea of a perfect cosmological principle and the idea of a Copernican principle, when taken together, imply the possibility of a perfect Copernican principle, which would generalize the conventional Copernican principle so that it applies to time as well as applying to space, as it, in the traditional formulation of the Copernican principle, it only applies to space. A perfect Copernican principle would assert that we do not live in a special region or era of the universe. Or if you prefer the formulation of Zhang and Stebbins' paper, we should not live in a special region or era of the universe. Given that the Copernican principle follows deductively from the cosmological principle, if the universe is spatially homogeneous and isotropic, it follows that there are no privileged observers because there are no privileged positions in the universe from which an observer might observe. The perfect Copernican principle would follow from a perfect cosmological principle, and, given material implication, the falsification of any perfect cosmological principle could not entail the truth of a perfect Copernican principle following deductively from a perfect cosmological principle. History undertaken in the Copernican spirit, that is to say, Copernican history, would be history written with the perfect Copernican principle as a regulative principle. If the task of history is to write cosmological history, or to write human history set in a larger cosmological context, which is more or less the task that big history has set for itself, we cannot do this and remain true to the perfect Copernican principle. A history of the cosmos from a human perspective, which is the only kind of cosmological history that we as human beings can write, is inevitably and unavoidably an anthropocentric history. And views of the universe entire from the privileged moment in time occupied by human beings, which is a small slice of the evolutionary history of life on Earth, and which is in turn a small slice of the evolutionary history of the Stelliferous era, and again, which is in turn a small slice in the history of the universe entire, is obviously unrepresentative on the scale of the entirety of the universe. Big history cannot then be Copernican historiography, though one could plausibly argue that big history is an eventual result of viewing the world from a Copernican perspective. In fact, I would make that argument. It seems that not only does the universe evolve, and not only do human beings evolve, but also the perspective that human beings have of the universe they inhabit evolves. And it evolves at the interface between human life and the universe. On a human scale of history, however, the perfect cosmological principle can be applicable. That is, if we restrict ourselves and we don't try to write the history of the entire universe, we try to write the history of humanity, there is a sense in which the perfect Copernican principle can be applicable. That is to say, if we restrict the scope of our history to the human tenure on Earth, something like the perfect Copernican principle obtains. No one period of history can be judged to be privileged over any other era of human history, and certainly not in terms of a perspective from within history to write history. And this is very close to Leopold von Ranke's dictum that all historical eras are equidistant from God. And this is something that many people have taken as the core of the idea of historicism. This isn't Popper's historicism. Popper's historicism is theoretical history and a predictive science of history. But the most common way in which historicism is used is that each period of history is taken on its own merits, which Ranke expressed in terms of a theological metaphor that all historical eras are equidistant from God. And I am formulating as a perfect cosmological principle that there are no privileged observers in time or no privileged observers in history. Each era has the opportunity to write what Hegel called original history for itself and of itself. And each era has the opportunity to write reflective histories of its own times taken together with all previous history. In this respect, later periods of history survey a greater portion of the human past, and so are privileged in respect to having more empirical content of human history at their disposal than their ancestors. But on a purely theoretical level, the expanding empirical content of human history is irrelevant. So this claim that I just made, the expanding empirical content of human history is irrelevant, probably sounds really strange. So let me try to explain. Copernican historiography is integral with what I call history in an extended sense. That is to say, extending distinctively historical modes of thought beyond an exclusive engagement with the past. History in an extended sense comprises both past and future, which are formally distinguishable, or might be better to say, which are formally complementary, however radically different they are empirically. Extrapolating historical modes of thought so that these modes of thought apply equally to the future as well as the past could be called history in an extended sense. To understand history from the perspective of the perfect Copernican principle, which is a little like trying to understand history sub specie eternitatis, to cop a Spinozist phrase, as it were, and thus to deprovincialize one's conception of history, to cop a Carl Sagan phrase, it is sufficient to see that unprecedented events are always occurring, always have occurred, and will continue to occur for as long as any events whatsoever continue to occur, and thus continue to supply a natural history to the universe. If our presence or our location in time, regardless of our presence, were singularly unprecedented, we would be justified in asserting that we live at a special time in history. But even a casual survey of history will show that there is always something occurring that has never before happened in the history of the universe. Unprecedented events occur with predictable regularity. At a temporal microscale, it could be argued that each and every new moment of time is unprecedented, as the structure of the universe in no way guarantees to us that time will continue to produce new moments. On the other hand, each new moment of time is a moment among other moments. That is to say, it is one of a class of moments, the totality of which class makes up the totality of time. So that each new moment may be as unique as each snowflake is unique, but all moments are alike in the way that all snowflakes are alike. Whether or not we see moments of time or snowflakes as being unique or being as all the same depends on how fine-grained an account of identity we bring to our analysis of history. So to fully develop the idea of Copernican historiography, it would be necessary, at some point, I'm not going to attempt this today, to analyze the conception of identity one brings to history and the scope, and to analyze more carefully the scope of history we are considering at any one time. This is already implicit when I noted above that restricting our scope from cosmological history to human history may yield a valid application of the perfect Copernican principle. An extremely fine-grained account of history will yield the absolute novelty of every moment. A less detailed overview would perhaps yield absolute repetition where there's nothing new. And that always makes me think of Ecclesiastes. The thing that hath been is that which shall be, and that which is done is that which shall be done, and there is no new thing under the sun. Or maybe not. This is something that I still have to think about further. Ecclesiastes' principle implies something like a cyclical conception of history, but more on this another time. However, I hope that you can see how this is related to the argument I made in Philosophy of History before Augustine, where I said that there is a naturalistic philosophy of history just below the surface of providential and progressivist philosophies of history. The idea of Copernican history is a naturalistic idea that belongs to a naturalistic philosophy of history. And forsaking Copernican history for non-Copernican history is an implicitly non-naturalistic position, even if that non-naturalism is not made explicit. So, thanks for listening, and happy birthday, Nicolaus Copernicus.